lines and rectangles that in his language meant relations between a man and a woman, which is quite complicated. But some architects took it even further, and by adding third dimension, created architecture. We used this idea to create a living space inside of our workshop. We use strips of fabric stretched between iron rods, and that create floors, walls, and tabletops. These are PCB-coated membranes that became rigid when stretched. Because of membrane, the rolls of membrane coiled in dry workshop take up little space and have a small web. But in wet workshop, when they are fixed to iron rods that also provide communication systems, they give us a space with huge compositional and functional potential. Here we can see a living space. We decided to create a living space that resembles the ones on Earth, with living room, bedroom, and private studies, only because this should help crew to identify with the new home that they will spend there like a year and a half. On the opposite of the main membrane, there is a place, a workspace for workout and science purposes. The study will contain tabletops with plexiglass terrariums for research into cultivation of algae in space. The mission have enough food supplies for whole its duration, yet to provide healthier and fresh meals. The crew will test usage of spirulina algae. To do that, they will use a device called Spiru. Spiru is the world's first bioreactor for the home cultivation of spirulina, and was designed by Polish design group and Polish engineers. Spiru has already proven itself in providing meals rich in vitamins, proteins, and unsaturated omega-3 fatty acids. But to stay in shape, they will also have to train a lot. There is some usual training equipment like treadmill or training rubbers that crew can work with, but the great volume provided by wet workshop led us to design a centrifuge, or that we call G-bike. Microgravity negatively affects bone tissue. Experience shows that astronauts lose some 1 to 3% of bone tissue after a month spent in orbit. We decided to create an artificial gravitation force using centrifugal force. G-bike is designed for two people that use their legs to spin the device, just like a normal bike. The angular momentum derived from G-bike should be equal to 0. That's why we need to use two bikes with equal mass that spins in opposite directions. Centrifugal force will be equal to 1.2 Gs at user speed level, and overall force stimulation will have to compensate negative effects of weightlessness on human health. To avoid dizziness, the crew will use virtual reality goggles like Oculus Rift that will project vision of a bike ride in a pleasant environment. Training schedule is included in a daily routine that you can find in our project. I don't know whether it's on your desks or not. Doesn't matter. And also it shows crews daily tasks during their 501 days flight. That includes scientific work, training sessions, and meals and free time. After spending over 500 days in space, the crew will begin the re-entry phase by rejettisoning Earth re-entry pod and the service module from the rest of the ship a few hours before landing, and perform necessary corrections using RCS engines. Then, service module will be decoupled from Earth re-entry pod, allowing the crew for the direct re-entry. Mission ends. Cost of the mission largely depends on final prices of both SLS and Falcon Heavy launch prices. But we can claim for sure that utilizing empty fuel tanks greatly cut the costs of the mission, as we don't have to launch additional habitat for the crew. Other costs we could predict more easily, like using deep space network or costs of other equipment on board. And taking all into account, we managed to design a space mission that is not only cheap, but also offers a great value for the price of $1 billion without launches, development, and so on. This concludes our mission proposal that emphasized on creating a safe and comfortable living space for future pioneers. Thanks to our inspiration with art and architecture, we could redesign the workshop concept that can provide large space that is cheap, easy to utilize, and friendly for users. It also allowed us to design a G-bike that can compensate one of the greatest threats, which is negative effect of lack of gravity on human health. With our slightly modified inspiration mass trajectory, we can address any structure or supply issue due to our 80% mass margin, which is crucial because every mission tends to put on weight during the development process. Well, good designs work, and we today saw a lot of good designs. Great designs not only work, but are coherent in form, structure, and function. They can give to user even by using simplest means. If you could imagine a TV commercial of such a mission, well, maybe not imagine because I'm going to show you. It starts with a question: what would you do living? What would you miss living Earth? And do you have to miss anything? And as you take off your VR goggles, you find yourself in a vast space that is your home. And we provide over 360 cubic meters of space. We provide unique training equipment that will keep you healthy. And as you approach Aero, you go to dry workshop, you're going to see your purpose of going on this trip. After spending 247 days, you finally reach Mars. And it doesn't necessarily have to be unpleasant trip. In fact, it could be very friendly, pioneer-friendly trip. Thank you very much.